is we worked with a company that makes electronic medical record software that wanted to host that EMR software in Amazon, right? And so we had them sit down, and they had never done this. I'm like, so what are you promising the doctors and the patients that use your product? Just make up easy ones. And one of the easy ones is users are not able to access the medical records, users being like doctors and nurses, are not able to access the medical records of patients belonging to other medical institutions, right? So if I'm Dr. Smith, I can't look at Dr. Jones's from down the street, Dr. Jones's patients. A basic assumption of how the security of the system should work, and then we kind of listed what kind of controls we want to put there. And we'll talk about that. So this is what our traditional 3-tier architecture looks like. We've got a web tier, an app server tier. These would be the same, obviously, if this was like a Microsoft stack, although you might still have like a static tier or a caching tier up front for accelerating this. And a DB tier. And between all those, we have at least virtual firewalls that provide layer 3 access controls between all those suckers. And then we have our corporation out here where our sysadmins sit and our IT folks sit, and they come through a firewall or VPN, probably something like a point-to-point VPN with some layer 3 access controls built in to SSH to these boxes or RDP to them or whatever. And then we have a support VLAN probably somewhere in the data center that supports multiple stacks of this web application, where we have things like our backup solution. Now, backup might be on its own network. We have our logging, our Bastion host, our SNMP, all of our monitoring stuff, our Splunk install these days, stuff like that. What's this look like physically? Well, physically, what we end up with is a rack of servers that go into top-of-rack switches. Those top-of-rack switches then have a per-port VLANing, right? So you have to go configure the switch as this physical port. I want to add this VLAN tag. And then those guys trunk the VLANs into a master switch at the end of the row, or in a different cage even. And then all of the layer 3 routing is happening in the firewalls over here, and our load balancers are probably directly attached to these guys. And our internet access comes in through here. This makes sense to folks? This kind of like what you've seen in traditional web architectures? Anybody want to say I'm wrong? No, okay, good. I just want to make sure I'm not oversimplifying for what people's experiences are. So what are we getting from this design with this physical backup? We're getting network segmentation, right? Control traffic and production traffic we're able to segment using VLANs, at least, although they're on the same physical infrastructure. We have very simple network configuration. Because we're slicing up by internal VLANs, the network configuration on the individual host is very simple. We just assign them a static IP within a layer 3 CIDR subnet that lines up perfectly with our layer 2 VLAN. Right? Now, there's a difficult thing is that we have to go and configure the switch every time we put a box in. But in these kind of traditional infrastructures, we're not putting boxes in all the time, right? Maybe just when we build out or when we do a major rebuild of our website are we actually racking and stacking, so the amount of network engineering time is not that bad. And what's enforcing this? Well, we have our custom OS on the routers, right? We have our custom OS on the switches, not no switches, on switches, sorry. And we have our custom OS on the firewalls, right? Why am I saying this? Well, lest people tell you that software does not give you good security from network segmentation, that you shouldn't use software-based network segmentation, what do you think is running on that 6500, that $25,000 switch that you bought? Software, right? Now, it's not software you can download off the shelf, but certainly what we've learned over the last couple of years, it's also not software that is bereft of any security vulnerabilities, right? The question is, does this still make sense? What is the attack scenario? When did this come out? This is like kind of the mid-90s, maybe, 94, 95, that this became the standard way of building enterprise web applications. What were people protecting against back then? What were the types of attacks people were... What would happen if a hacker broke into your site in 1995? Is anybody old enough to remember 1995? Sorry? Great, they face it. They would shout out their greets to their friends, right? And what techniques would they use to break into a website? What kind of bugs did people have in 1995 against web applications? Buffer overflows and web servers, right? Telnet, RSH, people having control channels exposed to the internet. People still had that, right? People would be like telnetting in over the public internet to control their web applications because, not a lot of people did lease lines or VPNs and such. Right. I only have 10 minutes. I better hurry up. How would I get to the database tier if in these good old days? Right, I defeat the web tier, and then what do I have to do? I have to break into the app tier, and then I have to break into the database tier using different vulnerabilities, right? Now, if SSH was exposed through all those and I had an SSH bug, then I use the same SSH bug, right? But that's what this is here for. This is to protect the idea of people breaking into the first tier and then using a vulnerability to break into the second tier and to break into the third tier. Is this actually how attacks happen these days? No. What happens these days, okay, yeah, so this is my traditional exploit, right? Is I have my exploit to the web tier, I have something like an app server vulnerability. I'm sorry, yeah. So that's our traditional exploit. But realistically, what we have are things like web exploits. Somebody said SQL injection. Any kind of normal web application bug automatically makes it all the way back to the app server tier and maybe hits the database tier, based upon the bug. And that is popped a hole through the firewall. The firewall gives you no benefit there. The other thing that we see, like in the Aurora attacks earlier this year, of which we were involved on the good side, we weren't actually the people in China doing them, is you see people attacking through the corporate network, taking over the local Active Directory domain within the corporate network, taking over a bunch of admins' desktops, and then using the credentials of those admins to log into machines directly, right? And these are the kinds of attacks that this traditional 3-tier architecture doesn't really protect against. So as a solution, if you take this off the shelf and you put it in the cloud, what you end up with is the idea of all these machines in tiers. Instead of layer 2 VLAN controls, we have things like security groups. You don't have to take pictures, I'll give you the slides. They're online. And those security groups often have a lot of traffic that can be routed within them, and then a very little amount of traffic can be routed between them, just as if you had firewalls on the inside. The interesting thing is that every single machine ends up with its own public IP address, although for most of these machines, the public IP address should look like nothing if you've configured it correctly. So again, problems with the classical, traditional cloud architecture is the classic network segmentation that we used to do here is now a lot harder, because instead of just assigning machines to a VLAN once and then using access control groups, we have to do a lot of per machine customization to pop these rules through. And depending on the provider, that can be somewhat easier or somewhat harder. But one of the big complaints about people moving up into the infrastructure as a service providers is that network configuration is a horrible grind where you have to come up with rules you want it to be, and then decompose that into what rules have to be enforced on every individual machine, and then push those rules out. Right? It's a lot harder than it is doing it on CatOS with VLANs. The per tier scalability is problematic because we have to add those access control rules, and we have to add the relationships between the tiers statically. How do you hook an app server up to a database server? Like if I need to add an app server to an additional web application, what do? I build an app server, I have to log into it, I give it the database credentials, I tell it what database to aim against, and then I have to log into a web server or my load balancer tier, and then tell it that this new machine is online. Right? So there's a couple of manual steps that are quite dangerous, and that's one of the reasons that most of that scaling happens during off windows. Right? Most traditional web applications are not able to scale their back-end resources during normal production hours. They have to wait to change windows, right? And you end up with the same problem in the traditional cloud architecture. Like I said, relies on the manual creation of relationships. And honestly, your DB performance is going to be pretty bad. The biggest complaint we hear from people that move up into the cloud is, oh my God, my SQL is so slow now, right? Anybody know why? Why shouldn't you run MySQL at Amazon? Well, it's because this guy has what's called an EBS volume, which is hosted on S3 on their distributed file system. That distributed file system is on tens of thousands of machines with locally attached storage, right? And so if you imagine, instead of one hard drive or one RAID array or one Clarion that this guy's hooked up to, you have a tier of thousands of hard drives backing it up. And when we have our single instance database, we take, every time it makes a request, it goes out to hundreds of different machines to pull that data in the distributed file system together. It sees one flat file, binary file that's like the MySQL database, and then it spreads out to the dozens or hundreds of web and app tiers, machines talking to it, right? So you end up with this bottleneck where you have data coming from hundreds of machines, going to 100 machines with one machine or one cluster right there in the middle. And that one cluster made sense when all of that data was on one single local attached RAID array or a fiber channel attached array. It makes a lot less sense in a situation like this. And you will never be happy if you go and you buy the biggest HP that you can buy, a DL 580 or whatever, and you hook up a very fast fiber channel drives to it, and that's what you ran MySQL on, you will never be happy at Amazon because they can't provide you with any instances with close to the same amount of CPU or disk performance on a per instance basis. They just can't. The difference is instead of spending $100,000 on that hardware, you get to rent that machine for 65 cents an hour, right? So it's the economics are a little different. So what's this mean? The alternative is that we go flat in our architecture, that we collapse the perimeter down to the individual virtual instances as much as possible. We use cloud glue services instead of manually created relationships, and we enforce our access control via cryptography. So go flat from a physical perspective. This is how this is how Amazon and all these guys are actually laid out, is you end up with top of rack gig or 10 gig switches with no VLANing and overlay networks on top that every machine has their public and their private networks on the same layer 2, right? So instead of having your layer 2 and your layer 3 networks line up from an access control perspective, you have public and private networks on top of each other within the same rack. And while there may be some network access controls, for the most part, these machines, which are the virtual hosts or droplets, have full connectivity to each other. I'm going to cheat because that guy went over, sorry. So what is one of the reasons these guys go flat? This is a switch that you can buy from people called Arista Networking. If you look really closely, you get 384 wire speed 10 gigabit copper Ethernet ports. And you have, 10 terabit lossless switch fabric, right? So you have 10 terabits of back-end switching between those 384 machines. This is the most expensive firewall you can buy from Juniper, the SRX 5800. How much switching power does it have on a layer 3 firewall? 120 gigabits per second. So how many of these would you need to provide layer 3 access controls between all of the ports on this switch at 10 gig speeds? How many of these would you have to buy? What's 10 terabits divided by 100 gigabits? 100. You need to buy 100 of these firewalls to provide layer 3 switching between all the individual machines on a 10 gig 380 port switch. Right? And it turns out that this is how people are building data centers. They're using dumb switches. This Arista, while it has some layer 2 and layer 3 special functionality, you're not actually supposed to use it. Right? None of these numbers actually line up with you using any of that functionality. What this is the most expensive Linksys switch that you can buy. It's a big, dumb, fat switch that very, very quickly looks at an Ethernet header, takes that Ethernet frame, and moves it to another port. It does that so quickly that you can have lossless switching between 384 10 gigabit Ethernet ports. Whereas this guy eats the Ethernet header, eats the TCP header, does layers 4 through 7 inspection of the inside of that TCP packet, recreates IP and TCP streams, right, in memory, does denial of service detection, does IDP, looks for exploits, all that crap. And it sounds great, but realistically, if you're building a rack full of very fast machines with 10 gig Ethernet, you also have to have an entire data center full of these firewalls to provide that level of security between them, right? And the only way you can get that level of security, like layer 3 access controls and IDP and stuff, is to spread that responsibility onto all of the individual hosts. And this is how cloud providers do it, right? Instead of having big firewalls that all the switching goes through, they push that responsibility to the hypervisor layer. And then every single hypervisor server is responsible for the network security for his 4 or 5 or 6 virtual machines, instead of for the 384 physical machines hooked up to the switch. And there's been some discussion that Google might have done this themselves and built their own 10 gig switches because they were tired of people having to pay something like $1,000 per 10 gig port when they realized all they need to do is go to Broadcom or whomever, who is it they talk about here? Maybe it's Broadcom and other people that just make like the SFPs, which are the actual things that turn the Ethernet information, the Ethernet frames into a packet that you can switch around in like an FPGA, and then you just use FPGAs and ASICs to do the switching and have no intelligence. That they're building 10 gig switches that don't even have SSH or terminal. There's no way to get to the switches. They're just dumb switches. And if a port fails, you unplug it and you plug into a different port, right? Just like really big Linksyses. Because economically, you can't really afford to do this, honestly. And I'm not beating up on Juniper. A Cisco product would be just as ineffective for this kind of stuff. Right? Like theoretically, you can put that firewall, blade into your 6500, but can you actually, if you have 300 10 gig ports on that 6500, and you put that firewall blade in, can you use that firewall blade on all those ports? No, not without actually losing all that performance benefit. So you have to collapse the perimeter. You end up using software firewall on a per OS or per hypervisor basis. For a lot of reasons, per hypervisor is much better, especially because a software firewall on an operating system provides you no protection against somebody rooting that box and then